Okay, so here's what I would suggest. Let's first talk through the meaning of edge, and let's devise a strategy and articulate that in English about how we would determine whether whether a pixel is an edge or not. We've got a proposal from Sharia. Am I pronouncing that correctly? Okay. That is a very good point. Okay, it's a beginning of something. So we want to look at the neighbors of the pixel, right? The pixel is going to be a part of the edge or not based on its neighbors. So that is a good direction of thinking. But let me share something, or actually, Adam, can you scroll one page back? Okay. Okay, yeah, actually, yes, that's correct. So we've got this pixel is different from function, which we probably want to use. And we should combine this little piece of advice from Ms. Taylor with a piece of advice from Sharia.
Oh, I think I get it now. Wait, if so we can do and we need a threshold value. So
Call it,
I believe the threshold value is like the difference off from the value.
how different do you want the pixels to be to call them an edge? Don't put a number there. Create a variable called threshold so that we can modify it in a single place and know what it means. Say 20, 50, I don't know, pick a number.
20, yeah.
Okay.
And then you have to put comma threshold.
Yeah. Now make sure that the syntax of what you're writing is correct and then try and execute it. And let's see what JavaScript tells us.
Oh, I forgot my curly bracket.
You forgot a bunch of things. Count the number of open parentheses. Start from the beginning of the line.
I forgot to close parentheses here.
This is why when we write code, we generally recommend building the habit of closing every bracket that you open first, and then inserting other stuff inside later.
Yeah, that's very good advice. Actually, many editors, many Microsoft Word-like programs that specialize in writing and helping you write code will automatically insert a closing parentheses when you insert an open parentheses. Yep. And the caret is between the open and the close. So you can just keep on typing and never worry about the closed parentheses. Okay, now
oh wait, I put the curly bracket in the wrong spot.
So the curly bracket goes after the closing open parentheses. There's no semicolon, just the open squiggly brace. Okay, run it now. Okay, so now we're good from a syntax perspective, but from a logic perspective, the code that you wrote is incorrect. For one thing, pixel.getNeighbors doesn't exist. If you go back a few slides, you can find what that thing is supposed to be called. and I wouldn't know how far back you have to go. So let me just copy and paste it for you, okay, from my own notes.
Oh.
Okay, so you are getting pixels out of an image. So logically, you cannot send a message to a pixel and ask it, hey, tell me who your neighbors are. The pixel says, I don't know. I just know about myself. So you have to ask the image, who are the neighbors of this pixel? Okay.
Maybe.
But you, okay, now try running that. And it's called,
it's source.
yeah, source. You have a spelling mistake in threshold. Too many H's.
Oh.
Huh, interesting. Pixel.getRead is not a function. Isn't that funny, right? We don't even have a getRead here.
Some buffer thing.
Well, actually, no. Read Sharia's advice. You are not following his advice.
For every neighbor in image.getNeighbors.
Yeah. So think about it. You are asking JavaScript to look at whether, you want to ask JavaScript to look at whether a pixel is different from any one of its neighbors.
Yeah.
And the fact that pixels are different is a property of two pixels, right? You look at two pixels and you ask yourself, are they different? Are they the same?
Yeah.
You can't ask the question, is this pixel different from these 9 pixels? And you're really asking look at your code now. You'll see that you're asking the question, is one pixel different from 9 other pixels? Get neighbors will give you 9 other pixels.
So it'd be for every neighbor in source.
Can I get Sharia to help out? Sharia, would you be comfortable hopping on the call and commenting on how we should be using your for loop? I will take that as a no, so I'll continue. So the idea here is that you have to ask the question about the current pixel that you're looking at and all the 9 other pixels that form its neighborhood. So this is an opportunity to write another for loop. So you're looking at every pixel, you're focusing the attention on one pixel at a time, but then you have to expand your field of view to the 9 pixels, the 3x3 square. And so as you expand your field of view, in order to look at the 9 pixels that form the neighborhood of the current pixel, you have to use another for loop. So right after for pixel in source, let's add another for loop.
For
I'm liking where you're going.
Another point to mention here is when you have a for loop inside a for loop, what we tend to do is put like 3 spaces in front of that line so that you can clearly see that it's nested. There you go, something like that, right?
Yeah.
And then keep doing that for, so like align your braces, align your.
Oh, that makes sense.
See,
Yeah.
now you can tell very clearly that, okay, that's for the outer for loop, that's for the inner for loop. And then the if statement would be the innermost one, which also should be indented, which then clearly explains now what's going on, right?
Though you may have a hard time indenting it because you just have so much code on that one line, which is fine.
Yeah.
So that's not,
Yeah.
so indentation is also something that is very important for readability and maintainability of code. But we're typing code in an HTML slide for a
Right.
presentation. It's not going to be optimal.
Okay.
Okay. Now let's see if what we wrote makes any kind of sense. Click on run. So get neighbors, it's good that you write, source like get neighbors, but get neighbors is a function. Okay, it's a thing that you call, and you need parameters, you need arguments.
Oh.
And what is the argument of the get neighbors call? Bear in mind my analogy with the zooming of an image, right? You're focusing in on a single pixel, and then you're zooming out and looking at the 3x3 block around that pixel. So in order to zoom out, get neighbors basically zooms out, right? In order to zoom out from the current pixel, you need to know what's the current pixel.
So,
You see my point?
yeah, so we need to know which pixel it is.
Right.
So we would do.
Well, look again at what Sharia suggests. Yeah, exactly. Yes. Okay, now we're back to the get read not being a function because we're using get neighbors incorrectly in that line, in the line below, line 8.
Get neighbors pixel threshold.
So now you have two pixels that you're looking at. Okay, you've got the reference pixel that's at the center of your image of the 3x3 square that you're looking at, and then you have one of the other 9 pixels.
Yes.
So what question are you really asking? What yes or no question do you really want to ask here?
Are these pixels different?
Right. Which 2 pixels are different?
I'm not sure I understand.
Well, in order to ask the question, are these 2 pixels different, yes or no,
Yeah.
you need to have 2 pixels, right? You can only ask the question, are these 2 pixels different, if you can name and point your finger at 2 pixels. Now, you have 2 pixels in your code right now. One is called pixel.
Pixel, yeah.
What is the other one called? Look at your next line of code. So you've got for every pixel in the source image. No, threshold is a number. Threshold is just a number. The line of code just under pixel says, let's read it together. For every
neighbor
in the neighborhood of the current pixel. So what is the neighbor, right? The neighbor is one of the 9 pixels that form the 3x3 square centered on the pixel.
Yeah.
So the 2 pixels that you're looking at are pixel and
the pixel, one of the 9 pixels neighbors, one of the 8 pixels neighbors.
Well, in reality, the get neighbors function returns the whole 3x3 square, including the one in the center. That doesn't matter, right? The point is, you've got a pixel called pixel, and you've got another pixel called in your code.
Get neighbors pixel.
Get neighbors returns the list of all the neighbors. Jacqueline has a suggestion. Read Jacqueline's suggestion.
The pixels and neighbor.
Neighbor, right? You're creating a variable called neighbor.
Yeah.
And you're saying for every neighbor in the list of neighbors of this pixel. So here's your 2 pixels that you're working with. You're working with a pixel called pixel, and you're working with a pixel called neighbor.
Yeah.
And now you can ask the question, are they alike? Are they different? Yes or no?
So if pixel dot is different from source dot get neighbors pixel. So this would just be neighbor
That would just be neighbor. That's right. And is neighbor a function?
No.
No, it's just a pixel, right? So you don't need to call a function using using the open close parentheses notation. I think there might be an extra parentheses. No, it looks good. It looks just fine.
Okay.
Okay, run it.
But then we don't have anything to do.
We don't have anything yet,
Yeah.
but what we're expecting to see is that it's not erroring out. It's not giving us an error message. Okay, nothing happened. We just displayed the result, without any effect.
Yep.
But at least, we didn't get an error. Okay, so now you have an if statement. And the body of the if statement is going to be executed if the pixel is different from the neighbor.
Yeah.
So what's your body? What do you want to do when you detect that a pixel is is different?
Then we would want to set it to white.
To set it to, no, when it's different, you would set it to black.
Oh, set it to black. Okay.
Yeah. Okay. So how do we do that?
Pixel dot set RGB. Then put 0, 0, 0.
Okay. Okay. It'll take a little while because this is a very, very inefficient way of processing images. Generally, JavaScript is not your favorite language for processing images, but the code that we're writing is actually very inefficient. It's okay. Like the point here is not to learn to write super optimized code. The point is to learn to write your very first, 10 lines of code. And I think we're doing a great job with that. Fact is, nothing at all happened. Now read through your code carefully and tell me why nothing at all happened. And if somebody has a suggestion, please send it to us on the chat. Think carefully. You're setting some pixels, not all of them, but some pixels you're setting to 0, to R0, G0, B0.
Yeah.
Where does that pixel come from that you are changing?
We don't know.
Well, we do know. I mean, you've
know,
written a
but
for loop.
So what we have here is what we call a simple code bug, and it's a very natural mistake to make. So this is where a debugger could actually be pretty helpful, but I don't know how you do that here.
Well, it's actually hard to use a debugger in this case because you don't have an exception. You don't have an error message that pops up where you can say, okay, well, let me stop the code one line before hitting the snag and let me see what's going on. Here, we just have to understand what we're doing because the program is executing correctly. It's just doing the wrong thing because it's been programmed to do the wrong thing. So when this happens, don't touch your code. Like before you start modifying your code, read through it very, very carefully and understand what the problem is. So read through it carefully and tell me what exactly you're setting to 0, to black. Because you're setting some pixels to black, but nothing is showing on the screen. Why?
Because it doesn't specify which pixel it's setting to black.
No, you're specifying it very, very carefully by saying if the pixel is different from the neighbor, then set it to black. You are doing that.
Maybe the threshold's too high.
There's a more fundamental problem. Read through your code. Maybe because the pixels are too small to see, says Indian Dynasty. Actually, this algorithm would set enough pixels to black that we should be able to see it. But you can try. I mean, set a threshold, set a smaller threshold so that it's likelier.
10.
Yeah. Now let's run it. And I'll bet you an espresso coffee that we'll get exactly the same image back. I'm pretty confident I'm winning a coffee here. There you go. You guys owe me coffee. Why? Read your code carefully. Okay. Line by line, start from the beginning. Tell me what every line does.
So the first one defines source. The next
And by the way,
one
guys, I just want to make
defines
a little
result.
comment here. Sorry for interrupting you, Adam. Just one little comment. I do a lot of interviews of engineers, and this conversation that we're having, Adam, sounds a lot
Yeah.
like many of the interviews that I've done, with folks that have gone through their bachelor's degree and their master's degree in computer science. So don't feel bad about, the mistake that you have in this code.
Yeah.
There's folks in their, late 20s with a lot of college education that would make the same mistake.
Oh, it should be result.
Oh,
There you go. You're my man.
Boom,
Yeah.
boom, 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 boom.
Okay.
Well done, buddy.
But the
That's
problem
okay.
is that setRGB is a function that is defined on, it's not a function, it's a method, okay, that's defined for what type of thing, for what type of object?
A pixel.
For a pixel. And result is?
An image.
An image. Now this is where, in order to actually set some pixel black or white, you need to go from one image to the other image. You have a pixel that you're looking at from the source image. You've made a decision about what you want to do, but you don't have yet the object that you will act on. So you have to use information from the current pixel to go fetch the right pixel out of the result image.
Yeah. So
Somebody's asking, what is result? Result is defined on line number 2. And source is defined on line number 1. They're both images. They are essentially the same image. Both poppy.jpg and poppyblur.jpg are essentially the same file. We're loading the same file twice so that we can use one copy as the source of information for the edge detection algorithm, and the other copy we're using it as essentially as a white canvas that we're writing to. So we don't really need to have the same image twice. We just need it once, and then we need an empty canvas to write on. And unfortunately, we don't have a better code base. The only way to create sort of an empty slate for us to work with is to load an image. Hence the need for the new simple image poppy.jpg and new simple image poppyblur.jpg. Okay, so back to Adam. So you still have result.setRGB. You can't call that because setRGB is a function defined on pixels. You have to find the pixel that you want to operate on. Let's call that new pixel that we want to find. Let's call that the result pixel. Okay, so define a variable.
So we put it in the if state.
Inside the if statement, you'll define a variable. Now be kind to me and use the let construct, okay, when you define a variable. As you can see, it's not required. Source and result are new variables, but they're not defined using let. I really don't like that. So at least in that one place, you'll oblige me and use let.
So pixel.
Hey, by the way, guys, like everyone try to pay attention to this because we're spending a lot of time, and it shouldn't be like an Alex, Adam, Shaurya show. There's a reason why Alex is spending so much time on this stuff. It's because this is basic stuff and very, very good, very useful habits to develop and understand. So please ask questions and let's make sure we get this right, okay?
And I want to point out that coding is a highly conceptual exercise, and yet you do not learn it conceptually. You just learn it by doing. So I want to give you as many opportunities as possible to step in and do the exercises yourselves on the call with the help of everybody else on the call, with the help from me and from Sanjay, because that's really how you guys learn, right? There's no point in me talking about programming unless I make you program.
Yeah, and then like math is like language. Practice, practice, practice. Somebody just wrote that. That's very true.
It's really good to learn more complex things if you don't really know your basics.
Right.
Hello?
I'm here. So
Oh, okay.
Adam, let's
Yeah.
go back to your code. So you're looking to define the result pixel variable, okay? So how do we get a pixel from an image? Let me help with that. I don't know that you've actually seen that, that function. So let me find it for you in Ms. Taylor's code. There you go. It's called getPixel. Rather, you know, rather simple choice of name, getPixel, and it takes two parameters, an X and a Y parameter. So let me type it up. Where's my chat window? Here's my chat window. Do you remember how to get? So you need the X and the Y coordinates. Do you remember how to get the X and the Y coordinates?
Pixel.getX, I believe.
That's right. Correct. Excellent. And we still have a problem. Oh, that's not the problem that I was expecting, though.
I think it's taking some time.
Interesting. There's obviously some weirdness in Ms. Taylor's code. There is a problem. There's a mistake here in your code that ought to have prevented your code from running at all. For some reason, it's running. I don't know why. But it should have thrown an exception. It should have displayed an error message. Can you see why?
Maybe it's because these are on different lines.
No, that's okay. Here's a problem. Look at lines number 1 and 2 and compare what you've written there with the line that you're currently typing on. You got source equals new simple image,
Yeah.
result equals new simple image, and then later on you write let result pixel equals image.getPixel.
Oh, it should be source.
It should, hang on. This is the result pixel, right? So where do you want to get the pixel from?
We want it.
Result. So the reason this instruction was not failing is because previously somewhere else in the code we loaded a variable, we created a variable called image, and it's picking up that unrelated image variable. That's an issue with JavaScript and a few other languages that are able to pick up variables from all over the place, and it's hard to know where the variables are coming from. One of the reasons I like to use let in JavaScript is it solves that problem. The let binding is only local, and you can't access a variable that was defined using let from a completely unrelated place in your code. But this gets a little too tricky. Okay, so now we have result pixel is result.getPixel.
Yep.
Get pixel x or pixel get x, pixel get y, and on the result pixel we're calling set RGB to 0. Did you run it?
I don't. Now I'm gonna run it.
Okay, I'm excited.
Ooh.
Wow. We're almost there. We
Fantastic.
almost got it right. What's missing from that? This is the opportunity for our product manager to step in and complain.
Looks like crap.
Okay, thanks. We appreciate your feedback. There's one part of the product requirements document that our friendly product manager has given you that you have not implemented.
Fine.
And by the way, I actually think it looks wonderful, so I like it the way it is. But if we want to fulfill the product requirements doc, there's one more thing we have to do.
Black and white image, so grayscale.
Yes. Well, it's not grayscale, it's just black and white.
Oh, so you can put an else statement saying that if it's not, it can set everything else to white.
Yes, exactly. Exactly. Now,
You guys finish this, then I have a comment later on.
you have a comment?
No, but finish this first. Let's not break the flow of the conversation.
Now you'll get something really unexpected, I think.
It's the same thing as before.
Well, let's
It's,
see. Let's see. Wow. How come everything became black?
Yeah.
Bear in mind, you're doing something that I think needs a little bit of an explanation. You are modifying the source while at the same time you are modifying the result. So in one branch of your if statement, you're modifying the result. In the other branch, you're modifying the source. But you're making the decision to modify the source or the result based on the values that you find in the source. In other words, your algorithm is deeply, deeply confusing, the way.
Yeah. And
But now you're fixing it by setting the RGB only in the result. Now the question is that the right way to do it? But run it and we'll see. Okay, we've had this error before. And now it tells you that result pixel is undefined. I will give myself a pat on the back. If we had used the version of variable definition that doesn't use let, you would not have gotten this error. You would have gotten a very unexpected behavior, but you would not have gotten this error because the let binding is local, right? The let binding only exists between the open squiggly brace and the closed squiggly brace. Whereas a variable that's, what's that?
So it's only in the if statement.
It's only inside the if statement. Outside of the if statement, the result, actually not just the if statement, it's inside the if true part. It doesn't exist in the if false part, in the else part. So if you had used the regular sort of old school 1990s version of variables in JavaScript without let, result pixel would have been created and would have been there, but it would have been the wrong pixel. So we're good in terms of what you're doing here. The problem is that result pixel needs to be defined outside of the if statement in order to be available both to the if true and to the else part.
Yeah. So I just moved it into the inner for loop.
Did you click on run?
Yeah, hit run. Run again. Oh no. Hello?
I was muted. Looks like it's taking its time. I think the algorithm that we're running is pretty slow. It's about as slow as they make them. You would, like I said, you would never actually implement a filter this way for real, but it's a perfectly fine exercise for us. And there you go. Now you've got your black and white version of the edge detection. And if you lowered the threshold from 10 to something smaller, you would get, more of the edges actually being detected. This is a successful implementation. It would be great if you could copy and paste it into the chat, I suppose, though it might not fit.
But yeah, this is awesome. So let me explain a couple of things I was saying earlier. I said it didn't look good. I didn't use a very good word, but actually it looked good. It looked fine. What I was alluding to was two things. First of all, some of the instructions were not perfectly followed, and the second thing is like some of this stuff looks kind of like blotchy right now. The stuff that it wasn't perfectly followed, where we still saw a bunch of color, and you guys had to go write an else statement to go set the other pixels that are not the edge to be white. That was specified in the problem, right? That's what we wanted. But the other part where it kind of looks blotchy that you see here, that was not specified, that I wanted you guys to remove the blotch. So that's an example of where the problem from a product management standpoint is not even correctly specified. And engineering did the best they could, and we didn't clearly say what we wanted, right? So there's kind of this interplay as well in computer engineering, computer science, between what is the desired outcome, who specifies that, who says what it should be, and then who actually implements it, and then are they talking the same language, literally. It's very interesting interplay.
Okay. I think this makes a perfect spot to take a little break.
I'm putting it in the chat.
That's wonderful. Thank you very much.
Okay.
Thank you.
In the chat.
Okay, so when we come back, I will show you a slightly improved version of the blur algorithm from yesterday, and then we will dive into the next lesson. Shall we resume at 6:40?
Sounds good. 6:40 is good.
Okay.
Yeah.
I'm going to step away as well, Alex. I'll be right back.
No problem. Sanjay, you back?
Sharia, I just saw you do it.
So have we identified the culprit?
It's Sharia. You can check the recordings. I saw it for a second when whoever's talking, when no one is presenting, it shows whoever's talking.
Yeah, I saw it too.
Okay.
Sharia.
That was fun.
Nice Hindi music though. Nice Hindi music.
Got busted.
So guys, whoever's on the call now, I need another volunteer. So please get all the courage you can muster and volunteer to lead the class in the next exercises. And we've got
I'll try.
Herman, logic error on line 11, XY out of bounds.
I'll try.
Who's there? Sharia. Okay, great. So this is what we're doing now. Hang on for a second. Okay, we're switching to a fancier algorithm than the blur filter. Actually, let me start out by sharing my own screen and showing you what we're talking about, and then Sharia, you can take control.
Okay.
You guys see my screen? Everybody okay?
Yeah.
Okay, awesome. So fancy filters. So we've used if statements. Well, we've learned all about that. Now we can get fancy about what we do with our if statements and the images that we're processing. You have the link. I will not show you the video. I think it's a little off topic and I want to save time. Have you guys heard of the term green screen from the TV or videos? Or, okay.
Yeah.
So we're implementing the green screen algorithm, right? It's called green screen because traditionally it's green, but it doesn't have to be green. It can be any color. The idea is to have a screen of a certain color behind the speaker, behind the anchor, and then we have a computer identify the pixels that represent the background and replace them with a background that we like better. For instance, on certain conference call software, the software will recognize the background and allow you to replace the background with a picture of your choice so that you don't have to show people, your bedroom. We don't have that feature. I don't think there is that feature in Google Meet, so we can't experiment with it, but we can build it ourselves, okay? So here's how green screen works. It works by replacing all the pixels of a certain color with pixels that come from a different image. And the color depends, we decide whether to replace a pixel based on the color of the original image, and we copy the color values, the RGB values, from another image. Okay. Now, this is one way to do it. It's sort of a super simple way. There's fancier ways that use machine learning and AI, but we like things to be simple right now, and so we're using that. So here's what the author of the class is suggesting. We have a picture that we want to modify. It's called image. And there's a green portion in the bottom right corner. And then we have information we want to copy from what's called back, the file called back. And so in the result, you see that the pixels, the little 4 pixels in the bottom right corner have been replaced with the same 4 pixels in the back image. I'm not sure that this diagram fully represents what we're trying to do, but we will work on it and get it to work. So how do we determine whether we want to replace a pixel with another pixel? Well, we have a function that is very similar to the one we used earlier. Earlier we had, what was it called? Is different from, and now we have is similar to. And it works in the same way, or similar enough. We provide a red, green, blue value. Earlier we were providing a pixel. Here we're providing a red, green, and blue value. And we're looking for all the pixels that are close enough to that particular red, green, and blue value. And number is the threshold. How different do 2 pixels have to be to not be similar? And if the difference in red, green, blue values is less than the threshold, then we consider them similar. So now this is a Boolean condition, right? We can invoke pixel dot is similar to with red, green, blue, and a threshold, and that will return true or false. That's a yes or no question. Okay, is this pixel similar to this red, green, blue value with this given threshold, yes or no? And once we have that yes or no question answered, then we can use set RGB together with an if statement to copy information from one image to another. Okay? What do you guys want to copy? I don't think there is a good specification of the problem here. Right? It just gives us space to work on, but it doesn't tell us what we have to copy. We could copy from Yosemite. What are they suggesting? They are suggesting copying from Paris into Yosemite. Okay, from Paris into Yosemite. What do we want to replace? I don't have, nobody is telling me what to replace, so I could suggest,
Paris
go ahead.
Background into Yosemite image.
That's what they're suggesting here. They're saying image is Yosemite. So image is what stands in the foreground, and back is the source of information that we want to use to cover up the background. So and we can change it if we want, but they're suggesting that we use Yosemite for the foreground and Paris for the background. So basically we have to pick a color from Yosemite that we want to replace with Paris. What do you guys want to replace? We could replace the blue of the sky. We could replace the gray of the mountain, or we could replace the green.
Or the mountain.
You want to replace the gray of the mountain. So the idea is to have a very odd looking picture where the sky is blue, the foliage is green, and instead of having a mountain between the sky and the trees, we catch a glimpse of Paris.
Yeah.
That's a little weird, but it works for me.
Yes.
Okay, so let's try that. Okay, I need a volunteer.
Shari already volunteered.
Yeah.
Oh yeah, sorry about that, Sharia. I have the memory of a goldfish. Yes, please.
Should I present?
Yes. Sharia, are you there? Are you sharing your screen?
He's trying to
I'm trying to right now.
hit the bottom right hand corner.
Present now and a window.
No, hit your entire screen. Don't hit
No,
window.
I already tried that.
No, hit your entire screen, and then click on that where it shows your screen, and then hit share.
It's not letting me.
Try clicking on your. Okay, try window then.
Are you guys in the same place?
No.
We live near each other. Yeah, I can't share.
Well, that's a pity. Okay, so we could do it this way. You could remote control me, and I will be your secretary typing up your instructions.
Okay, that can
How about
work.
that?
Yeah, that should work.
Okay, so let's read through the code. We've got image equals new simple image, yosemite.jpg, and back. Okay. So what do we want to do now? For setting, this is an interesting function called set same size. So let's go look it up. Kind of curious what it does. Set same size.
Mom!
Set as big. It scales. Yeah, I have some serious doubts that this actually works. We'll give it a try. What it's doing here is it's finding a scale factor between the two images, and it's applying the scale factor to the width and the height of back to match as closely as possible image, but it's not going to match exactly unless the two images have exactly the same proportions. So we'll just use the code the way as Taylor has set it up for you, and if all else fails, then we'll change the set same size call to something else. But let's assume that everything here works well. So what do you want me to type?
So basically what we're trying to do is replace the mountain with the Eiffel Tower, right?
Replace the mountain with information, with pixels from Paris, which will contain parts of the Eiffel Tower and parts of whatever else there is here. You know, there's some of the sky, and I guess we'll get some sky, some clouds, and some Eiffel Tower.
So we would have to write if pixel similar to, then we have to figure out the different values for the red, blue, and green.
Yeah, I have a great idea for that. I'll call them R, G, and B, and threshold. Okay.
You need to define RG.
We need to define them. That's absolutely true.
R is equal to let R.
And R is equal to, I don't know, let's say 100. We'll change these later.
Yeah.
Let G is equal to 100. Let B is equal to 100. And then let threshold is equal to, I don't know, 20, 30, 40, don't know. 30.
20.
Okay. And by the way, I have no idea whether this particular syntax, the let statement, works outside of the squiggly braces in this particular setup. It does. Yeah, no problem. Great. Now this does not work though. Why does it not work? Because where does pixel come from? We've never defined pixel.
So we can define what the pixel is.
Okay, how do we define a pixel? How have we done it so far?
If pixel is blank.
But pixel doesn't exist. Read the code. Image equals. So we've set the image.
Menu.
I don't even have enough space to use the let binding here. So we've got image, we've got back, we've got R, we've got G, we've got B, we've got threshold. We don't have a pixel anywhere.
So we would put let pixel be equal to blank.
What is the pixel equal to, right? I don't know. The point is we're not working on a single pixel, right? We want to work on all the pixels of an image.
Yeah.
So how do we do that?
So what we're so if we wanted to use multiple pixels, then wouldn't we have to? We wouldn't want to define every single pixel. So wouldn't we would have to use a loop.
There you go. So what do I do? What do I write?
So if pixel is similar to RGB threshold, then
You were telling me about a loop.
yeah.
Right? You wanted to use a loop. And I told you, yeah, I'm very excited about that idea. How do we write a loop? Right? We want to operate, we want to do something to an entire image. So we have to do it on many, many pixels. Really, on all the pixels of the image. Well, how do we do something on all the pixels of the image?
Well, actually, I was thinking we could use an if-else statement. If like pixel, we still have to define pixel is similar to RGB, then let RGB be equal to the different pixels from the parentheses. Else.
Okay, so you want to use, what happened here? You want to use pixel.set RGB.
Yeah.
Yeah, something like that.
Yes.
We don't know exactly what goes in there, but we'll figure that out. Point is, I still don't have a pixel. Does anybody on the call have a suggestion for how I can get a pixel to be available to me so that I can call the is similar to function? I need to get pixels out of the image. And
Get
Sharia,
pixel.get.
Pixel.get.
well, you can't get a pixel if you have a pixel. Right? Pixel.get wouldn't mean much. But we can get pixels out of an image if we have an X and a Y coordinate. Now, the point that I was trying to make is we want to use all the pixels of the image. Now, and Sharia correctly pointed out that that's a use case for a loop.
So we would have to, would we have to loop that? We would have to say, we would have to get the X and Y coordinates for every single pixel.
We could, and there's a type of for loop that works like that. It's called a numeric for loop, where you say I want a certain number to start at 0, and I want to increment it until it reaches 1,000, and then you can execute the body of the loop where the number is equal to 1, and then the number is equal to 2, and then the number is equal to 3, all the way to 1,000. But that's not how we've looked at loops so far. We've used the for each loop. And I've been very particular about reading the heading of the loop very carefully. And I've used language like this. I said, for each pixel in the image, do this. All right, that's the for each loop. So how do we write that?
For curly brackets? Or
actually round brackets.
Yeah, parentheses.
Normal.
Pixel. Semicolon, colon, image.
There you go.
Yeah.
Let's see if I can indent this. I can't. Not in one fell swoop. Okay. But I still want to indent, so otherwise I'll get lost. Okay.
Okay.
So now we have the general idea in place. We are iterating using a for loop on a collection of things is called iterating, where we are iterating. And actually, let me spell that out for you guys because I think it's an interesting word to have available. We are iterating, okay? And iterating means that we are performing an iteration, okay? Or actually many iterations, one for every pixel. So we are iterating on all the pixels of the image. And for every pixel in the image, we're asking ourselves the question, is the pixel similar to some predefined RGB values at a given threshold? If yes, we want to set the RGB values to be something, okay? The question is, what do we set the RGB values to? Well, this is a good time to go and inspect the content of the other image that we want to get information from, okay?
Okay.
So where do we get the information from? What's the image that we want to get the information from?
The back, the Paris scene.
The back, okay, the back image. So let's define another pixel. Let's call it the source pixel, like we did earlier. Okay, source pixel is equal to, what do?
Back, basically.
Back.
Dot.
I want to find a pixel. So
get pixel.
Get pixel. What do I need to provide to the get pixel function for it to work?
X, Y coordinates.
I need an X and a Y coordinate. So we'll say X and Y.
Yeah.
You know, I want to make my names a little bit shorter because I want them to fit on one line. And unfortunately, the line is super short. So I'll call it src pixel instead of source pixel, okay? Then we'll have let x.
Can you stretch that window or no, it doesn't work?
I tried many, many times with no success.
Don't worry.
No, I don't think we can. So we'll have to make do with a limited space. So let x. Well, what x coordinate do I need to get? The x coordinate of what pixel do I need here?
You need the coordinate for, like, not specifically the Eiffel Tower, but something around it.
The back pixel.
But the back pixel is called source pixel, right? Source pixel is taken from back. Source pixel is back.getPixel. We don't have the source pixel here. And we can't have it because in order to get the source pixel from the back image, we need the x and the y coordinate of some other pixel. Bear in mind, we have two images that overlap one another, okay?
Pixel.image.getPixel.
You're saying image.getPixel. But again, getPixel wants an x and a y coordinate, which is a problem, right? We don't have an x and a y coordinate yet. We're trying to find an x and a y coordinate. The point is,
back.getPixel x, just x, since it's wanting to get an x.
So what do you want me to write here? Tell me again.
Basically the same thing as back.getPixel, but instead of putting x and y, just x, since you're trying to find an x value.
So I'm happy to try it, but what do you expect JavaScript to tell us when it hits this line of code?
Pixel's not defined.
Interestingly, it's probably finding x's who knows where. Again, the problem is JavaScript. In JavaScript, there are these variables that get defined in the global scope, and they're available everywhere, which is a really bad programming practice. And unfortunately, JavaScript is, like I said, it's a language that originated many years ago. I would say probably about 30 years ago, and it had a very different design to it then. But the modern version of JavaScript is still compatible with the old. Oh, what happened?
I think.
So here's the problem. Here, I'm defining x in terms of x. Have you guys ever heard? Let me finish this thought. Have you guys ever heard of the problem with defining a word using the word itself?
Yeah,
Can I give a
you can't do that.
You can't do that, right? Now, I don't want to be so stark as that. Recursive definitions, they're called recursive definitions. In math, they can be done, but this is not a good way to do that, right? We really have a problem. We're saying invoke the function getPixel using x, but I'm not telling you what x is until you've given me the result of this function call. So this is really not a good form of recursion. We can't do that. The point is we already have a pixel here. I want to point out that we already have a pixel here.
I think where it says let src pixel equal back.getPixel, what you need to do is, I believe you need to do pixel.getX, comma, with arguments, and pixel.getY with arguments.
And that would be right, but I like to use lots of lines of code because lines of code are cheap. Yeah.
Yep.
Now this makes sense. Now I have a source pixel, okay?
Yep.
Now I have a source pixel. So now we can do let, we already used RGB, which is kind of unfortunate. I want to change the names of these variables because I want to make it clear what they stand for. They are the, let's call it the screen R. So we're looking for the green screen, right? So I call, but it's not really a green screen. It's a gray screen in our case. But I want to use the term screen RGB to signify that this is what we're looking for as our virtual green screen. And then we can use RG and B to mean something else elsewhere. Okay, there you go. Now that we have the source pixel, we can define the source pixel R as src pixel get red. Let src pixel G src pixel get green.
Yep.
And I spelled it wrong. Let src pixel B equals src pixel get blue. And now we're happy.
Yep.
R, the src pixel R, src pixel G, src pixel B.
Yep.
Do we need to do anything in the else statement?
Well, not really, but if we need to, then we can put something in there.
Yeah, but for now, I'll take it away.
There's no use. Ooh.
Now look at this. We've actually replaced parts of the mountain with stuff coming from Paris. Turns out that in the particular part of the image where the Eiffel Tower would have been, we didn't get a lot of the transparency that we wanted because we probably picked the wrong color, right? I would need to copy and paste this image into GIMP to find out the exact value of color or of gray that we want to replace. But let's just try to be more generous with our threshold. Let's use 60. And now, as you can see, there's a whole lot more that's coming from the Paris image. I do think that this code from Ms. Taylor, set same size, doesn't work. It's not doing the right thing. It's supposed to make the two images have the same X and Y coordinates, or basically the same width and the same height. And I've tried it a few times and it really doesn't seem like it's working correctly. So let me replace that with something more appropriate. Set size. Okay. So we'll do width is equal to image get width. Height is equal to image get height.
That's not how you spell height on the lowercase one.
Thank you so much. Thank you so much. Width and height. And here, instead of set same size, we'll use set size. And I think it wants width and then height. Width and then height. Width and height. Okay. I'm not sure that the difference was significant. And now we really got Paris showing. We've got too much Paris, frankly. So maybe 100 is too much, but it's showing that it's working. There you go. Now we're starting to see the Eiffel Tower without deleting the trees too much. Okay?
Okay.
Is that fun?
Yep.
I do want to point out, guys, that we started, oh, too much scrolling. We started at the beginning of this class. Gosh, I really can't control what screen I'm on. We started this class a few days ago, only a few days ago. What was that, a week ago? Not even.
I said, you give me what you want to give me, so she loaded
And
Actually,
a week ago, maybe. We didn't have any prior knowledge of programming, right? We started with a very basic introduction about what the computer is and how it works. And now we're writing green screen code. We are merging images. We're selecting the pixels that we want to replace from an image with the pixel from another image. And we're getting Paris to appear in the mountains of Yosemite. I would argue that's pretty cool. What do you think?
this is like the basics of what you would see in a movie for a green screen.
Yeah.
Yep.
Yeah. like I said, this is not how it's actually implemented. This is a very, very slow implementation. But the real implementation does the same thing. It just does it using the GPU, using the video card, using fancier programming languages that are appropriate for processing images. But other than that, the idea is just the same. So I want to point out just how far we've come in only a few days. Okay, how many of you think that this is crazy? It's insane. Your brain hurts, and you're not getting this.
Sometimes.
It's valuable. Go ahead.
I said sometimes it gets confusing, but then I understand it.
Okay, that's very valuable to know. So it's very important to me to know if some of you are just not getting anything that we're doing, because I need to make sure that we are communicating at the right level to get all of you to come forward with us. But we have come a tremendous way from the very beginning. Okay.
It just gets hard to focus sometimes. So, yeah.
Okay. And trust me, I know that programming requires extreme concentration because you basically have to think like the computer. And I've stressed the fact multiple times, read through the code, understand exactly what you wrote. In order to understand what you wrote, you really have to think like the JavaScript runtime, and you have to execute the code in your mind and say image equals new simple image. Okay, now this line of code creates a simple image object and stores it in a variable called image. And then back equals, width equals, height equals. You have to keep all that information in your mind about what does the image variable contain? What does the back variable contain? What does the height variable contain? What do all of these instructions mean? And what is the state of the program at every point throughout its execution? This does require a tremendous amount of concentration. And software developers who do this day in and day out, often they work on large projects that have many, many thousands of lines of code, often millions of lines of code, if not billions. I have no idea how many lines of code Google has, but it's probably billions. Every engineer who works there is familiar with a large fraction of that code. Maybe they're familiar with 100,000 lines, 1 million lines of code. And of those million lines of code, there's several thousand that they know by heart, that they are working on currently in the last week or so, and they really know everything by heart. That's the level of familiarity that you need to really be super productive with programming. And that speaks to the level of concentration that you need to be able to do this successfully. So yes, it takes a lot of concentration for sure. But I do want you guys to feel very good about how far we've come. Okay, we've been implementing in the last day or so, a couple of days, we've been implementing some really, really fancy algorithms using doubly nested for loops, iterating over an image, comparing pixels from one image to pixels from a different image, copying information from one image to another, and implementing something as fancy as a green screen. Or even as an edge detection algorithm. That too is pretty fancy from my perspective. Good so far?
Yes.
I think in terms of how much time we have, this is a very short lesson today. There's the faded green screen algorithm, and there's the triple green screen where we're merging 3 different images. I'd like to leave those for exercises. Sanjay,
Homework?
Let's call it homework. Yep.
Okay.
Sanjay, what do you think?
Yeah, I think that makes sense. I mean, guys, like if you want to try it, there's a lot you could learn from it. If you don't try it, I mean, that's fine if you get the stuff conceptually, but if you're really interested to learn the concepts and the programming aspects of it, then please try it.
Okay then.
Somebody is suggesting pasting the code. I can paste it in a better place. The doc.
For the end, yeah.
Okay, thank you. I gotta go.
Why did it not copy and paste? Okay, bye everyone. Somehow it's not Now it is.
Okay.
Thank
It's there. I checked.
Okay.
Yeah, it's there. Okay, cool.
Okay, bye everyone. Thank you for joining us.
Bye.
Bye-bye.